Racket. Hello, this is Wilson. I'll keep this video short because I'm pretty tired, and I ended up playing Pokemon Fire Red for hours. Like for 2-3 hours I played it, and it's really bad. It's really bad. I mean, I shouldn't have played it because I made an hour-long video, but I played more than that. Actually, I defeated the 6th gym leader. This can't continue, but yeah, once I finish the game, I don't think I will. I am close to finishing it as well. It's just 2 more badges left. But still, I'd have to train my Pokemon really hard. I'll upload the video and then you can watch the video if you guys are into Pokemon. But I'm glad I'm using Linux because if you don't have much gameplay and video games on Linux, so then it just destroys your addiction completely. I'll try not to play that video game tomorrow. Yeah. So yesterday we were here, and so it says before we do some real programming, let's look at one more kind of data, spice things up, images. When you insert an image into an interaction area, hit return like this. So Dr. Racket replies with the image. In contrast to many other programming languages, BSL understands images, and it supports an arithmetic of images just as it supports arithmetic of numbers or strings. In short, your program can calculate with images, and you can do in interaction area. Furthermore, BSL programmers, like the programmers for other programming languages, create libraries that others may find helpful. Using such libraries is just like expanding your vocabulary, and with new words or your programming vocabulary with new primitives. We dub such libraries such as teach packs because they are helpful with teaching. Can I copy and paste this image? Okay. But I don't think you're supposed to have this arrow. But I don't think you're supposed to have this arrow. To insert images such as this into Dr. Racket, insert menu, copy paste the image from your browser into Dr. Racket. So let's have a look at Rocket. Team Rocket. Yeah, you have Team Rocket in Rocket image, Dr. Racket. Yeah, this book I got it from PDF. So yeah, see, like I was gonna say, it's colored, but as you could see it there, but here it's black and white. Rocket image. Let's just type that. Rocket image. Yeah, let's copy this image and paste it here. It's a good image actually, good quality image. So to HTTP you have to require, yeah, without this command it won't work. I did many questions related to this. I should start doing that again, yeah, so let's try this. Image width, star, image width. So it's got arithmetic of this. So like it says here, one important library with 2HTTP supports operations for computing width and height of the image. And there are a lot of, in that course, the OSSU course, it's actually given by edX, you have a lot of these. So let's run this. I'm pretty tired for some reason. I have to do more programming now. But like I said, I spent the whole day playing that game. I should stop now because 5061. Oh, that's cool. That is cool because that's the area of image of a 28 by 42 image. This is clearly not 28 by 42 and it's much larger, but it's still cool. You do have Google to find images and insert your own Dr. Racket program with insert menu. You can instruct Dr. Racket to create. And yeah, this is the brilliant thing. They call even circle a primitive if I'm not wrong. So you can create a circle like this. I should remove this. Yeah, functional programming is very enjoyable. Functional programming in math is just amazing. Rectangle, 30, 20. I have to use view in my app, but I don't want to. I'm very reluctant to use view, but also you need to know like JavaScript before that, but without view I won't be able to finish the app. So here's you use driving circle and rectangle, and thinking about that is just making me a little bit more nervous. When the results of expression is an image, Dr. Racket draws it into the interactions area, so you see it here. But otherwise BSL deals with images as data that is just like numbers. In particular, BSL has operation for combining images in the same way it has operations for adding numbers or appending strings. So yeah, overlay, and you will use it a lot in those questions. Overlay, circle, it's a different circle. Yeah, it's smaller because I was thinking of let's just copy and paste it. And programming is a lot about just copy and pasting code. Rectangle. This has to be brought down to 5. And this is more like a square because like the length and the breadth are the same. So now you have this kind of image, which is a Japanese flag. Actually, if you have a rectangle and that in the middle, then overlaying the image in opposite order produces a blue square surface. Stop and reflect for a moment. Last result for a moment. As you can see, overlay is like more like string append than plus, but it does add image just like string append adds. But it does add images just like string append adds strings and plus numbers. Okay, so let's say reverse the result. If you do this, I mean, I think what's happening is that the circle is so much smaller than the rectangle that you don't see this. Oh, interesting. Solid blue. It wasn't supposed to show that, but it is showing that. So, oh, it is. This is the error. It's just solid. Yeah. So when you have an outline, it doesn't cover everything. Like the center is left open, but when you have solid, then see, small bugs can appear. You got to think when you're coding as well. As you can see, overlay is more like string append than plus, but it does add images and blah blah blah. This is what I just read. So image width square 10. But what's the point of this? I think it's just like it is removing this out when you're doing the image width here. It's like 20 because it's probably covering everything. These interactions with Dr. Racket don't draw anything at all. They really just measure the width. Empty scene and place image. The first creates a scene, a special kind of rectangle. The second places an image onto such a scene. Let's try this. This seems interesting. I think previous one just calculated the width and so we don't need it. And width is not important for a circle because it has a radius. I mean, that may be it, or it's just probably because like it's not calculating the area covered by that image. Place image circle 5 solid green 50 80 empty scene 100 Let's see what we get. We didn't get this grid actually, and you get this. They said there'll be a grid, but there's no grid there. God only knows why. Empty scene 100. You do definitely get this, but you don't get like grid. Not quite. The image comes without a grid. You see, we superimpose the grid on the empty scene so that you can see where the green is placed. See? Yeah. So when you're reading it word to word, you miss out some things. How much is this? So we'll finish this part. As you can see from the image, origin 0, 0, it's downward upper left corner. Unlike in mathematics, the y coordinate is measured downward. Okay, so you have probably x and y. You have the y-axis like this in math, and then probably here in computer science it's more like this. Yeah. This is the y-axis. So this is the y-axis in math. Y-axis in math. I think that's what it's trying to say, and this is y-axis in programming, or at least in Racket. It's downward, not upward. I think we can highlight this. I think this is why you need a lot of linear algebra for this. I had stopped doing the OSSU because I thought I would just need like I don't have enough time. But I think studying computer science is very important for this kind of stuff. So we'll remember this. Otherwise, the image shows you should have expected a solid green disk and the coordinates 50, 80, 100. Otherwise, the image shows that you should have expected a solid green disk at coordinates 50, 80 in 100 by 100. Let's summarize this again. So probably the origin is somewhere upper left here. So we probably place it 50, 80. So 80 is downwards, so it's probably going down here. So 1, 2, 3, 4, 5, 6, 7, 8. So because 80 is downwards, you get 50, 80 here. And in mathematics it wouldn't be 50, 80 would not be here. 80 would be somewhere around here, and 50 would be somewhere around here. This is 1, 2, 3, 4, 5, 50 and like 80, something like this. So 50, 80 would be something like this actually, if it was math. But because the y-axis is like there, so you have 80 somewhere there and 50 somewhere here, and it won't be like this. Otherwise, the image shows what you should expect, a solid green at in 100 by 100. Let's summarize it again. The program is to write down an arithmetic expression, but you are no longer restricted to numbers. Okay, so to program is to write down an arithmetic expression. So basically, this is the main idea, that y-axis is different in programming, and if you calculate it like 50, 80, like now the grid makes it easy. This is 1, 2, 3, 4, 5, 6, 7, 8. So 50, 80, and then this is probably 1, 2, 3, 4, 5. Oh, it's probably 6. This is so. But if you measure it one from here, 1, 2, 3, 4, 5, and this is 6. So I don't know why it's getting there. But you get the idea. At least the 80 is there. Let's summarize. To program is to write down an expression, but you're no longer restricted to boring numbers. In BSL, arithmetic is arithmetic of numbers, strings, booleans, and even images. To compute those still means to determine the value of an expression. So yeah, basically doing something like this. Basically to compute is to get the value of this kind of thing, like getting the area. So it was 17 something. So basically that's the computing. 50651, 50561, that was that. Is to determine the value of the expression. So that 50561 that you saw, except that this value can be a string, a number, a boolean, or an image. And now you're ready to write programs that make rockets fly. Okay, so I did a lot of that. I have to still program. I haven't done any programming for the day, so I'll end it here. I'm sorry for the short video, but if you want to watch that Pokemon video where I killed that Articuno, you can watch it there. Like and subscribe, stay tuned for more. Consider donating through PayPal, and peace out.